everyone. It is great to be here today, and it is great to welcome all of you to our very first seminar, Metran's research seminar for the semester, the weird semester of 2020. And in this weird semester, all of our seminars are actually webinars. And that's very good because all of you can sit comfortably in your homes or wherever you are and be able to join us today. We have a great speaker to line us all up, but before I start and introduce the speaker, I do want to point out that we are very pleased that this particular seminar is jointly sponsored by two TRB committees. The first committee is on women and women and gender, and the second one is on travel behavior. And we are actually very delighted here today because we've got Dawn Hood, who is part of the Women and Gender Committee, to say a few words and welcome us from the committee. So I'll turn it over to Dawn.
Thanks, Jen. As Jen said, I'm Dawn Hood. I'm with the University of Minnesota, and I am chair of the Women and Gender in Transportation Committee, which up until this year was formally known as the Women's Issues in Transportation Committee. Our committee focuses on illuminating the importance of gender differences in all aspects of transportation. We were born out of the Safety and Data Committee, and over the last 4 decades, our work has expanded beyond gender differences in crash risks to include differences between women and men in travel behavior, preferences, and attitudes. We talk about crash risks and outcomes, about responses to construction and operation of various transportation and freight vehicles, concerns about safety and personal security. We talk about policies and experiences in the transportation labor force. That just gives you a small sense of the large portfolio of work that this committee is interested in working in. We are excited to start our fall academic season with this webinar series, and we thank Jen and Vicki for inviting us to participate. The committee plans on a series for this whole year on a number of different topics. We would encourage you to sign up as a friend for our committee through TRB so that you can see our future webinar offerings, and we hope to have you as engaged members of our committee in the future. I believe we have time for the travel behavior chair to say a few words, but I know he was...
Oh, I'm here.
Yes, he's here. All right, I will hand it off then.
Oh, thank you. Thanks, Dawn. Good afternoon, everyone. Well, it's afternoon here. I'm not sure actually just what time it's for you guys. I'm Kostas Mohammedian. I'm a professor of transportation system, University of Illinois at Chicago, and I'm also the chair of the AEP 30. The new name, actually, just the number. I'm trying to get used to this number, formerly known as ADB 10, Traveler Behavior and Values Committee. The committee has been part of TRB for a very long time. Actually, today's speaker, Kostas Goulias, was actually the chair of this committee probably 20 years ago, as if I remember, that was the first time I joined the committee. So the committee is concerned mainly with promoting research on traveler values, attitudes, and their behavior. When we talk about travel value and attitude, we usually refer to motivational and cognitive and situational factors that determine human behavior. And by traveler behavior, we usually refer to modeling and analysis of their traveler demand. And for that, we use different theories, and we use that usually those theories coming from various scientific fields. And I believe today's actually just talk, Kostas, is going to be touching on some of those actually the theories and fields. we are very excited actually to be the co-sponsoring actually of the seminar. And as Don mentioned, I should also encourage you to join the friend list of the committee. We have a very long, actually just this, we have over 1,000 friends who are helping us for the paper review. We receive actually just every year more than 150, sometimes more than 200 papers for the committee, very active committee, and we look forward to working with most of you. Thank you.
Thanks so much to both of you. We're really glad that you're able to join us today. Now let me move on to introducing Kostas Goulias, whom I have known for many, many years. As you've already heard, he was a former chair of the Travel Behavior and Values Committee. He's been at UC Santa Barbara for a while now. And before that, he was at University of Pennsylvania. He is one of the foremost travel behavior researchers in the United States. Anybody in the field knows who he is and has read some of his, yes, listen to this, 300 papers and reports. At the rate he's going, heaven only knows what he'll be able to produce in the next 10 or 20 years. I'm not going to say too much more. He's been, on all sorts of editorial boards. He's gotten awards. We're very happy to have him in California, I should say that, and have him be a part of our Pacific Southwest University Research Center. So without further ado, I introduce to you Kostas Goulias, and he will be speaking for about 40 minutes, and we will have time for Q&A after Kostas presents. So thank you, and Kostas.
Jen, thank you very much for the introduction. You made me blush. You cannot see it on the screen, but I promise you I did. I'm humbled by the introduction, and hopefully I can do justice to the good words you all said. So let me give you a little bit of background on where this research comes from and where we think we are going to be going. We started 3 projects with PSR on analyzing behavior of people. And the initial thought was to look at equity and who gains and who loses by the way the transportation system is designed, who is dedicating more time for the benefit of others, and what does space have to do with all this. The background is, of course, policies in California, where we think we are going to squeeze more people in the same land use, and hopefully they will stop using their cars and they will walk and bike. So that was the original idea. As we were going through the data analysis, we remembered, because we should have, the women issues that were discussed many times in the committee that Don presented, that men and women are different in many different aspects, but as you will see for some of our research, women are not different out of their own choice, but out of the situation in which they're put in. So that is one of them, and one of the issues that underlie the tasks and the duties that different people have. One way to look at that is fragmentation, and I will define fragmentation a little bit. But I can tell you already the conclusion of the talk that women have more fragmented schedules, and women tend to stay at home more. So these 2 extremes. And I will repeat these 2 extremes as we go through. I don't do anything alone for a long time. A lot of the work is done with my graduate students, Elisa McBride, Adam Davis, Rong Sang-soo, and Jinky Sao. And whatever you will see here is reflects quite a bit of their good work. but definitely with the sponsorship of PSR. So what you see in front of you is an example of a typical fragmented schedule. So a person wakes up in the morning, takes the kids to school, then goes to work, then eats a meal with the colleagues, run maybe an errand during lunchtime, goes back to work, then maybe goes to a social event, back to work again, picks up children from schools, goes shopping, returns home, and then escorts a child to soccer practice, do some work using mobile technologies during soccer practice, escorts the child back home and works at home, and eventually sleeps. So this is not mythical. This is not a made-up example. This is from a travel diary that we analyzed. So the question is, does this person have a life? Does this person have any personal time? Is this good? Is this bad? So, and a writer, a geographer named Lucas, he analyzed different data and came up with this social exclusion, that maybe people experience social exclusion either because they cannot leave home, so they stay at home all day, or they have so much to do during the day for others that at the end of the day, they do not have any personal time. And that's another form of social exclusion. It's called time poverty. So what you will see through here is that maybe we have low fragmentation of activities, stay at home and do all the work and all the chores at home. And we see this happening with people with disabilities, maybe in poverty levels, unemployment. But high fragmentation is the indicator of time poverty, where obligations leave no time for personal leisure. And here is an example from our region, here in Santa Barbara and San Luis Obispo. This is a diary, and it shows 5 different persons. And 2 of these persons, one living in San Luis Obispo, is a single woman, age 65, retired, with disabilities. And you can see that makes short trips around home during the day. In contrast, another again, single woman, age 58, disabled, works exclusively from home and never leaves. And then, contrasting all this, is a family from Santa Maria. And one person has a very long commute from Santa Maria to Goleta, which is about 45 minutes. And then other people have long trips, but one of them is escorting a child to school and then picks up the child again and spends quite a bit of time taking care of this child. This is an example of a child that felt sick when went to school, and the other person, the second adult of the household, went to pick this person up. So this is the schedule. These are 40 minutes in the schedule of persons, and they have been coded as at home, at school, at work, some other place, or traveling, the gray. So this is the spatiotemporal pattern that we analyze. So how do we view these patterns? The usual approach is to look at daily number of trips, modes used, distance traveled, and that is uninformative for the type of analysis we want to do. We want to look in detail to the schedules of people, compare different schedules and classify them into groups, and compare the schedules of men and women and see if the data can tell us what are the differences. So in the first example, I will show to you data that have been coded as at home, traveling with a T, at work with a W, some other place, and school. So when I look at the pattern like this, it says that this person in 24 hours, in 40 minutes in essence, stayed 830 minutes at home, then left and traveled for 10 minutes, then arrived at work and stayed there for 320 minutes, then traveled again for 10 minutes, and then stayed at home for the remaining 270 minutes of the 24-hour period we look at them. So it has location and duration. This is a string or sequence, and we will analyze many of these and find out what people do in a day by looking at the strings. This is a very simple one destination out of home pattern, and does not have a lot of fragmentation because you can see the big part of the time allocation is in one location. Another person will have a similar pattern that does exactly the same sequence, but it has different travel times. So when we apply what is called a sequence analysis, is a specific group of techniques, we can distinguish between these two because they have different durations, even though they have the different destinations. And they have the same number of trips, but because they allocate different time, there are different schedules. And that's why we use the analysis methods you're going to see here. So if we were to look at this in the 24-hour period and color code the different locations, home, school, work, other, and travel, we end up with a schedule like this. And this is actually a 5-person family that has one worker or person that works during the day. You can see actually at 12 noon, this person takes a break and goes for lunch. And then the 2 children that go to school with the orange color dedicated to school. One of the children goes to school for a brief time. And person number 1 happens to be the mother in the household. Number 2 is the father. And you can see, because of the coincidence of these periods of time and the traveling, that actually the mother is taking the kids to school and also takes care of them and travels in the afternoon. So the designated driver in this case is the mother that is fragmenting her schedule to take care of the needs of the kids. And that's the story that recurs. Just as an example, here is her schedule during the day. She visits only other, because for her it's coded as other, the school location of the kids, and has the many trips. And you can see that the segments of activity and duration are many more than the rest. In contrast, person number 5, which is a child, has a much simpler schedule, just goes to school and stays there for 405 minutes, but it has some of the schedule fragmentation of the mother because the children happen to travel together. We know this is a recurring story of the designated driver to escort children to school. So what we need to come up with are some indicators that tell us who has more fragmented schedule and who has less. And one way to measure it is with the well-known indicator of entropy, that it tells you in reality that it gives you the probability of the proportion of time that is allocated to a specific activity, travel, home, school, etc. And then the indicator shows that high entropy means a person spends a lot of time in multiple different activities. Zero entropy, person stayed at the same location all day. This is not enough as an indicator, but because we want to know the variety of combination of subsequences within a schedule of a person. So that's the reason we use this sequence analysis and the subsequence in addition to entropy. We are looking at the schedule you saw here, and we say, okay, what are some of the subsequences? We exclude H, and then we say, okay, one subsequence is T, O, T, O, T, O, T, and so forth. So we enumerate all this, and that is one way to account for this complex schedule, and enumerating all the sequences, for example, of this simple pattern, the HTWTH, independently of what it is, it gives you a phi coefficient of 27. And then we can use this in an indicator. I'm not going to go through the details, but it's in the sequence analysis literature that comes actually from computer science and genome DNA analysis. An indicator called TX indicates, captures how much variety is in a person's schedule. And this variety is a function of the variance of the time allocations in each episodes of the activities that people do. And just to avoid analyzing the math, I can tell you that if I stay at home all the 1440 minutes in a day, I will have only two subsequences, the null and this, and then my entropy will be 0 and my turbulence 1. So those are the baselines. And then as my schedule gets more and more complex, the number of subsequences increases, my entropy increases because of the variety of allocation of time to different activities or places, and so does the turbulence, and this turbulence captures all the combinations of possible subsequences that it can have. A simpler method is to use the entropy, again, by looking at the transitions from one activity to another, and that is called complexity. The reason I'm telling you all this, to tell you, is because we use regression methods to compare men and women, and also some kind of graphical method to compare men and women. So I need to give you also an overview of the indicators. So we look at the same type of schedules, and this time we added this other indicator, complexity, which starts with 0, like entropy. So a person that stays at home all day gets 0. A person that does many, many things in a day and breaks the time into small segments has a much larger value. So we have indicators that tell us whether or not a schedule is fragmented. We know why the schedules are fragmented. We know how to measure it. So let's see a couple of examples. And I will use the California Household Travel Survey, that is a one-day place-based diary. I happened to be also the management consultant during the data collection, so I can see, unfortunately, my mistakes reflected in the data, but what can you do? It's too late to fix it. It spans a year between February 2012 to February 2013. We have about 114,000 people from 45,000 households, oversampled the rural environments in California. And every location in the diary has also the top 3 activities at the location. And it was designed in this way to enable activity-based models. Data collection was done with a combination of paper and pencil, computer-aided telephone interview, and online. And it has many other components offline. I can tell you the goodies that you can get out of this survey. For example, we have a long-distance travel that is very, very important, GPS tracking onboard diagnostics. So to test the feasibility of the methods we use, we did first a pilot using the San Luis Obispo County and Santa Barbara County, and you can see some of the statistics. We use only 2,663 person days, and if you remember, entropy reflects the variety of allocation of time in different places. You can see the reflection of people staying at home all day, and then how it goes up and down as a distribution. These people have very, very many things they do in a day, and they go from place to place. Turbulence on the other side, this one value of 1 shows the same thing as in the entropy. Oops. But it also tells you that we have a bunch of schedules that are simple, and then we have the more complex. So some of the research questions is who is more likely to have complex daily patterns, and whether or not we find daily patterns to be complex in the cities. On the suburbs, we expect the cities will have more complexity because they have smaller distances and people can walk and bike from place to place. The suburbs are further away, so maybe not. And some of the questions we asked was, do we have more complex patterns and more fragmentation during weekdays versus weekends? And of course, the key item, are men and women any different? So this is just a technical detail because of the large amount of data. The value of 1 in the turbulence, we had to use a Tobit model, and we use a variety of social and demographic variables. So I will show you just the graphs and not the models. One of the questions is, how do people at different age groups have more variety in their daily schedule, and what happens with the fragmentation? So you can consider turbulence as a synonym of fragmentation, and you can see that children, very young children, and older persons, seniors, have simpler schedules. They leave home, they go to school, they come back, or they leave home, they go to shopping, they come back. But during this period, the age 25 to 54, is we have the highest fragmentation. Why? Oh, because these persons are picking up and dropping off their children, and they take them to soccer practices, and then they run all kinds of household chores. So we know the story there. This is very interesting to me because I usually develop activity-based models, and it tells you that fragmentation in this sample is different it's very different in each day of the week. So this is the day of the week nature. We knew that Sunday has a low fragmentation because it also has lower number of trips. It's the day where we stay at home and get ready for the week. But look what happens from Monday to Wednesday. Then there is a drop. This is a peculiarity of the small data that we're using. So in summary from this pilot is that the young children have simpler schedules. Older children have more complex schedules, and adults, of course, and their parents have the most. We also found that it is, in fact, the complexity of schedules higher for urbanites and suburbanites, which means they do more things than their exurban and rural counterparts. And you can read in both ways, negative and positive. The negative would be, well, the suburbanites, if they do more things than the other people, it means they use their cars. But then the urbanites walk and bike, and they reach activities, and they have higher accessibility to opportunities. We know from other research, exurbanites and rural residents tend to make less trips, but much more vehicle miles of travel because they have to spend more time reaching opportunities. We also found differences in terms of the poverty and disability that inhibits the complexity of patterns. Usually they stay at home or they visit just to one location. And we also found that the very young children actually inhibit living home or complexity, presumably because they're too young to drive them around like we do with all the other aged children. So this all is good. It passed the pilot. It works very well. It is consistent with the literature on travel behavior. So this gave us confidence to take this method to the entire state. But before we do that, we just looking at the fragmentation and then sequences and all these things, it doesn't make a lot of sense to see the patterns. So what about if we consider this sequence of 40 minutes, with each minute classified with a letter? It can be anything we want, activity or location. and we compare the sequences of different people that we observe. And then we apply clustering to find out what are the groups of these sequences that we derive. And there is a whole literature on how you cluster these sequences and how do you decide the optimal number of clusters. And I won't bore you with that. But the bottom line is we compare one sequence to another. In this comparison, we do it numerically. And really the essence of it is you look at one sequence of numbers and letters, and then you compare it to another one by performing operations of the type, if I switch this letter to another letter, how close do I come to a comparison sequence? So at the end of the day, you take a matrix like this and you apply cluster analysis to this, which simplifies the problem. The output, different groups that we are going to get, will look like this. So this is a 24-hour period. This example is from NSTS, starts at 4 a.m. and ends at 4 a.m. the next day. And we create a stacked bar for every minute of the 40 minutes. And different colors represent persons that spend time at this activity. For example, brown in this case is work. So for example, at the end of the day, we find everybody in this group of people at home at about 12:30 at night. It captures the break that people take during lunchtime, and they buy a meal or go for shopping. Some people exercise late in the evening and early in the morning. So if you draw a vertical line, you see how many persons in percentage participate in each of these activities. And you can see travel, this red one is throughout the day and reflects picking patterns of travel we see for the regular commuters. This is, for example, the regular commute. So for the San Luis Obispo Santa Barbara pilot, when we did all the sequencing and all the analysis, we find 6 representative patterns. We have the blue, the work day, typical 8 to 5 working with a break at lunch, and then levels off in the evening very soon. By 6 o'clock, most people are at home for dinner with the family. We find the school day without the break for lunch, because lunches happen at school, and the picket pattern of traveling, and the errands day. People that don't go to school or work go out and do other types of activities, and this home day. And I want you to remember this home day because we're going to see it being repeated. What is new about this analysis that we are doing, now we have 2 other patterns with substantial amount of people out of the 3,000 sample that we're using. Some people left home and went traveling outside the region. Some people returned from outside the region into home. And this is important for us that do modeling, because these 2 patterns usually are forgotten when we do modeling and simulation. So it was good for as background for what we are missing in our usual models. So this was valid for Santa Barbara and San Luis Obispo. It's strange region, maybe does not represent the state. Why don't we expand the whole analysis to our entire state? Since we have the California Household Travel Survey, just to remind you, we have about, at this time of the 2011, 12, 13 data collection, we had 39 million people, of which almost half are workers, and 1 million business establishments. I gave a talk in Europe, and the density of California is similar to Spain, for whatever it's worth. So we are not any denser than a normal country. So when we repeat the same type of sequence analysis cluster, and we come up with representative patterns that we see in the data for the entire state, we had to sample because it's a time-consuming data collection. We see the same basic patterns. The typical 8 to 5 commuter with a non-typical commuter that has different beginnings and endings of work, some of them very, very, very late. The school pattern is consistently the same. We know this is the most fixed schedule you can imagine is the one of the children that go to elementary school, middle school, and high school. Errands can be different this time because we have a wider variety of special opportunities. So we have two errand day types. Home day is quite big. We call it a home day not because they stayed at home all day, but because they stayed for most of the time at home, but then they went out for some activity. And the traveling is still there, living home is still there, and mostly out of home comes out as patterns. So now we have high resolution on the type of daily patterns. We are in trouble in terms of the modeling because living home, mostly out of home, and traveling are three patterns that we usually do not have in simulation models. And this traveling contributes quite a bit of VMT, and it's also part of this long distance traveling that we know in California we have to take into account. We looked at every one of these patterns and we analyzed the data within them. We also looked at what percentage of time they spend traveling over the amount of time they spend in activities. The amount of time you spend in activities is usually positive utility, you like it. Usually traveling, especially in congested condition, is negative utility, you don't like it. But what emerged clearly is something that always bothered me and will always bother me. The typical workday and the sort of typical school day are characterized by driving alone and being a passenger in a car. So this is the commute, driving alone in a schedule of a person that repeats it every day, the 8 to 5. The non-typical is a little bit higher in terms of percentage of alone, but not that much higher than the typical. The other part is, of course, parents take the kids to school, and 61% are doing that. There are other patterns in this that have high percentage of driving alone, but this emerged as very high. So let's go back to the initial question and look at men and women. Because we have a larger sample now in the statewide analysis, we can look at couples that allocate their time and compare the schedules of the two with that fragmentation idea. And originally I was comparing people that are a man and a woman independently of difference of age. Of course, I have a much smarter student than me, Elisa McBride, who created an algorithm and identified couples that are close in age and presumably partners. So the very first slide I will show you is for a man and a woman living together, but not having children. So the first portion is for a man and a woman living together and both working. And you can see this is the complexity indicator I showed you before, that they're not very different. They're not different at all, actually. Only a little bit of standard deviation. And the shape, the men are blue and the women are in orange color. And the shape of their distribution of the complexity is also similar. So no difference, really. When we look at couples or partners, and the man is working and the woman is not working, the complexity is much higher of the schedule of the man. So employment has outside the home has an impact, which means the non-working woman stays at home. You can see the spike here at 1, so social exclusion again. But when we look at couples in which the woman is working, then we see the flipping of the roles. So again, you know, the working woman has more complex schedule than the non-working man, with the spike of the man at home staying at home. Now we look at couples that have children. So when both partners, man and woman, work, the woman has a higher complexity than the man, and they have children. The woman has a higher complexity than the working man. When only the man works with children, the woman does not work. Yes, we see staying at home during the day, a small portion. But then, if I look at the complexity, the woman's complexity, the fragmentation of the daily pattern is lower, but not that much lower. And when the woman works and the man does not work, then obviously the pattern shows a higher complexity than men. So women have always higher complexity than men, and this brings me to the first set of findings. Remember in the beginning we asked who is more likely to have complex daily patterns? Well, workers with kids, and especially women, and this is the first indication that they face time poverty. We do find more complex patterns in the urban and suburban environments. This is interesting for those of us that are interested in autonomous cars and ride-hailing services. So complexity with more variety in modal options goes hand in hand. And yes, of course, all days of the week are different. Again, we're in trouble with the type of simulation models and policy analysis we do, because we still operate under the typical day of the week. It does not exist. The women have the more complex patterns, leads to time poverty, etc. And the children play a variety of roles. The very, very young inhibit complexity. The older children increase complexity because they need to be driven around. But when they reach 16 years of age, apparently things change in a completely different way, because now we have another driver, another car in the household. But disability impacts pattern complexity in a negative way. It forces people to stay at home, which means social exclusion again. Let me go back to this household responsibility hypothesis and give credit where credit is due. Some time ago, Professor Niemeyer used to be at UC Davis, now he's in Maryland, so that women take care of work, kids, and household chores. And that was called the household responsibility hypothesis. And evidence from our own research shows that this is clearly demonstrated when we ask a question like, for whom you do an activity. In the typical activity and travel diaries, we cannot ask this question. But by looking at fragmented schedules, by exploring looking at the coordination of schedules among different household members, we find that yes, in fact, women face time poverty because they take on more tasks, the household chores, taking care of the kids. So again, the social exclusion can happen because you cannot leave home and you have to stay in, or we are super active and for other people and you have no personal time. So this type of analysis worked. We are happy with the results, and the correlation with personal characteristics and life cycle stages leads to powerful explanation of scheduling dynamics, very, very useful for activity-based models, very, very useful for analyzing SB375 policies, correlating these patterns with different density, diversity, mix of opportunities. But just using location classification of home, work, school, or other is too limited. And California Household Travel Survey is becoming old because it was done almost 10 years ago. It was designed 10 years ago, was the data were collected 7 years ago. So and we wanted to try using the 2017 California component of the National Household Travel Survey. And our motivation is also because we have a project on telecommuting, and then we wanted to explore also what happens when we also include as an indicator working from home. We also want to add something else, which is the motives. I'm going to spend a little bit of time talking about this. Just a reminder, the California House, the NHTS, the California component of National Household Travel Survey, was collected between April 2016 and 17, spread throughout the whole year to represent the year. It includes weekdays and weekends. I'm going to use the data only of weekdays here, which means Monday through Friday, excluding the national and state holidays. A motive is something that comes out of the network analysis people, and is the representation of a schedule of a person as nodes and links. So in this case, this motive is very, very simple: work, home, and 2 trips in between. This is a little bit more complex: home, work, other, with that is work-based, the other. And you can see the arrows that represent the trips. So we will add this representation to the time of day schedules we saw before. The other locations, we count only the unique locations. So if somebody went 5 times to work, is going to get this type of pattern. And when we classify everything we see in our NHTS, we have the typical home to work and back, the majority of the motives, or a person leaves home, goes to work, goes grocery shopping, comes back, or the person from home goes to work, comes back, and when at work, goes for lunch and comes back. So these are the patterns. And these 16 patterns capture about 80% of the daily schedules. We also became more ambitious with the sequence analysis. So now we paint the type of activities with many more colors, or we classify them many more activities, and we add also the drop-off or pick up someone. This is the service activity that I was telling you before. Usually are allocated to the mothers from what we see, and change type of transportation because people can switch modes, and we want to see how this changes the schedule. So I will not go through all this, but we added shopping for service, shopping for goods, exercise, recreation, and visiting friends. So when all is said and done, we combine now the pattern of locations and trips in between with the time of day pattern, and then we classify the person days of people into a group 2 when they have 2 nodes in their schedule. You can see again the repetition of the typical work day, the typical school day, the home day, and now we can see what people do when they stay at home and they don't go to school or to work. They buy goods, they go out for a meal, and they exercise, right? And then we have some weird patterns, although there are many of them. And you can see this light green is is home and work. It is indistinguishable for how long people telecommute in this pattern because of how the data are coded. But you can see that this is clearly very, very different time of day pattern than the typical work day, which is a key finding for telecommuting. When we look at 3 locations, home and two other locations, again, we find typical work day, typical school day, home day, and the strange pattern again. Well, when we look at 5, and we again, typical work day, school day, home day, and the strange. The strange pattern is no longer strange because now we can see it repeating itself in multiple cluster analysis. When we take this group of many more distinct destinations that people went to, and they have different motif patterns, again, we see the typical work day, typical school day, the typical home day, the strange day, but now they start to be differentiated because obviously we have more diversity. Remember in the beginning, we were talking about people that stay at home all day. Of course, there are the persons in this data that stayed at home and they did nothing else and they reported nothing else. But we also have, and they are not included here, but when they did leave home, we found also different patterns for them. Some people that stay at home all day, they give a ride to somebody. They drop off or pick up somebody in the early morning, very early morning actually. When they work from home, again, they drop off and pick up people. So there are many telecommuters that also function as the escorting persons of the children to schools. And then there are some people that have wide variety of schedules and they end up in this pattern. So key findings, the home days as a pattern is the most popular. And many regional simulation models do not pay attention to this or do not pay sufficient attention. They just say, oh, did you stay at home all day? That's enough. And they don't look at other things. In fact, just before this webinar, I was in a peer review panel for the models of Monterey, San Luis Obispo, and Santa Barbara, and we were talking exactly about this distinction that we need to make in the models. We also see clearly something that is very, very interesting for the active living, for the persons that study active living. People that stay at home all day, they have what they're called the loop trips. They go out of home to walk the dog, go for a walk or a bicycle exercise, and we need to account for that when we study policies to enable people to be able to do this more active living around their homes. Typical example, bicycle paths and safety around bicycles that surround the residential areas. After all this research, one of the mainstays of transport geography is that people use homework and school, the 3 anchors, in their daily schedule. This is alive and well, particularly this period that most of us are forced to stay at home because of the way our work is scheduled. Home is becoming the major anchor around which we organize everything we do. But we found tremendous heterogeneity of behavior. So the analysis that has been done with daily summaries is not enough. We need to do this time of day and spatiotemporal pattern recognition. It is classifiable, the techniques exist, and they provide new insights. The patterns that I showed you have strong correlation with person characteristics and day of the week. I gave you a sample of what we found in some of this analysis, but the same repeats for the NHTS. But one key finding, this is for a project with PSR, telecommuters do not stay at home. They accumulate quite a bit of VMT. In some other analysis I don't show you, they don't travel alone as much as the non-telecommuters, but they do not just stay put. So the gains that we are hoping to get from telecommuting, I don't know. We have to analyze the data a little bit more carefully. We are doing some other research with these ideas. We correlated these daily patterns with the propensity to own an autonomous vehicle using data from the Puget Sound region. And we find some interesting results. I won't talk about them. We also analyze life cycle stages and daily time allocated for the benefit of self and others. And that's quite a bit of strong evidence that actually women dedicate more time to family and relatives. But men on the other side dedicate a lot more time for the benefit of co-workers, giving them rides, doing other things. So I don't want you to think that we men are totally selfish. We just show our altruism in a different way, maybe. We started correlating daily patterns to land use, and we already found actually the urbanites having more complexity in their patterns, but then we have to also verify that the types of modes that they use and the vehicle miles of travel that they use, because this is a major policy indicator that we use in California. Of course, we published quite a bit out of this with my graduate students, so I will have it in my presentation for those of you that want to follow up with these ideas. And with this, I thank you very much for your attention. And of course, we got funded by Pacific Southwest Region, Caltrans, and some internal funds. And with this, I will stop share and pass the baton to my moderator. Thank you.
Thank you. Amazing. I'm going to say world tour of travel behavior research at this point. We have a few questions that have come in. And I'm going to start with a question about income and ethnicity. So have you been able to parse any of your results, sort of looking at whether different levels of income show different patterns than what you showed, or different ethnicities?
Yes, they do. So there is a, you could expect it. Income and ethnicity actually are correlated. We all know that. So as I would expect, I expected that. When we look at, we have indicators in the models. So and the race is what they code as white, Hispanic, and then maybe African American and Asian. And we find that Asian and whites tend to have higher propensity for higher variety in their schedules, and they use their car more. But the income, this is another invention of Elisa McBride. Income, we did not look at income categories, but we looked at income as a threshold of poverty, which is a little bit more complicated to do. So you just find out what is the level of poverty for a single person, a couple with kids, and so forth, and you code that. Poverty inhibits traveling and variety of schedules, exactly the way disability does. So going back to the social exclusion idea, that's the reaction of people that are below poverty. They simply don't have cars, and even if they have a car, they cannot run it. And because the private car is the king in California, and public transportation is not exactly where we want it, or people don't live where public transportation is, then we see this reflected in the survey. But yes, the answer is yes, definitely. When you do the right analysis, you do find a strong correlation.
So one of the things that always strikes me when I see new research coming out is that gender roles continue. And there's been so little change in gender roles over basically decades. And despite women going to work in large numbers and so on, despite all kinds of changes in social behavior. And one of the questions that I got was, when is it not the woman?
And this is not coming from this research, it's coming from a different research. When traveling requires a long distance, the man that takes the car and the kids there, and I've seen this in data from Pennsylvania. So that's when it is allocated, and when we give rides to customers or co-workers, etc. That's when it's not the woman. But the household responsibility hypothesis for household chores, home chores, and children is consistent throughout not only our research. Somebody named Jonathan Gersuni from UK analyzed time use data over centuries. So the finding is striking because it shows women decreasing their household chores, the amount of time they spend dramatically over the centuries.
Right.
Why? Because of mechanization, automation, dishwashers, washers and dryers and things like that. And men stay stable over centuries. You know, this is amazing. So, but I will say something, and I don't say it. I say it on purpose. When I was in Pennsylvania, a visiting scholar came from Holland, and at that time she was studying emancipation of women. And at one discussion that we had in the talk she gave, she said, it's not about emancipation of women, it's about emancipation of men. It is the men that have to get, developed further, because we don't take on the tasks. That's now. How does that link to policy? I have no idea. I really don't know what policies will do, transportation policies. But labor policies can change quite a bit of things. Germany does that. So, but that's beyond our seminar.
Yes, I know. I couldn't, the question was perfect, so I really wanted to bring it up. Let's change the topic a little bit. And as you know, there's all this speculation going on that all of us who have been basically forced into working at home is going to generate, a big shift in the future, even post-COVID. And so, first of all, do you see that sort of shift actually happening? And secondly, do you see any potential changes in travel behavior than you've already observed with telecommuters? Should there be a dramatic increase in telecommuting?
So that's a great question. That's a really great question, and Kouros is participating, so he can add something. Data analysis from places like the University of Maryland maintains a dashboard of data that extract patterns out of the traces of phones, so that before COVID, we were at a certain level of percent of people that stayed at home because you track their phone and you see that they're safe. Then this percent went up. More and more people stayed at home because of the lockdowns and because of fear. And then this percent starts to decrease over time. So we know people start to reject telecommuting forced by the employer. We also see the amount of travel increasing after the first phase of telecommuting.
Right.
Now we are in the second wave, and we don't have lockdowns. So now we see the behavior of people. So big portion of persons are returning to travel. They're not going to work, they're going elsewhere to work. because they're avoiding their home and the people that are at home. And in California, many of the children are at home. So there is this conflict of work and family. So what we see is different locations of work. And this, I think, is a reflection of a trend that was already happening, that many people work from different locations. Their workplace is no longer fixed, and now it's becoming more flexible. This has implications for travel. This is worse than having the regular home to work, because now people will travel around, stop at the coffee shop, do 2 hours of work, go to another place. So a lot more travel. So travel might increase. I think Kayakshausen also has some data from Europe. This is Kayakshausen, a professor at ETH, has a monitoring, an observatory of this. And his data from Switzerland show that people went back to work, went back to traveling, and they're not using public transportation because they have the social distancing. But then I see from Southern Europe reports from mass media that they show metro wagons and buses that are packed with people wearing the mask, but nevertheless they are packed. So there is quite a bit of uncertainty. What I believe, and I'm going to guess now, is going to happen to California. We're going to see more solo driving, driving alone to avoid the carpool with people you don't know if they have COVID-19, the formalized carpool, and avoid public transportation because you don't know if it is disinfected, you don't know who is there, and because owning and operating a car in California is very, very inexpensive when compared to other places. So, sorry, I expect even more VMP out of all this. That's the bottom line.
You showed us, people, for example, with disabilities or, elderly, who have very small, what I would call activity spaces. They don't travel very much, and they travel, during the day on short trips and things, or they may not travel at all. For at least some of these people, there are others who are doing their traveling. So
Yes.
others who are going to the store for them or taking them places or whatever. Is that visible in the data?
It can be. For a traditional diary like the one in NHTS, if they live together, if they are in the same household, then we will see who did the grocery shopping or did other things during the day. But we have to make an inferential jump, not statistical, but it's a logical. We see it clearly in a survey that I designed in Pennsylvania. It's a time use open-ended diary in which we asked, what did you do next? What did you do next? Typical time use. But then we asked, with whom did you do the activity and for whom? And when you ask for whom, you can see clearly, for example, things like, I'm so glad you said this example, because I have a very, very interesting example that I use in my class. There is a family that, because the sample span the entire week, is Sunday, this family goes to church. And I see a father and mother and the kids, and they go with 3 cars. So when you analyze this, you say, 3 cars to church? Why? Right? So one of the persons during this stays at the church for just about 40 minutes, I think, if I remember correctly, and then leaves and goes to Walmart, and then goes to another place, and then comes back to church. And for whom, she wrote, to pick up, for whom did you do this activity at Walmart? To pick up medicine for father. So her father did not live with the household, but lived further away. That's the other location. So this is something that we are not able to capture with the traditional diaries, even if they're place-based, because we are not asking questions to the father. We are asking just questions to the parent. So we would see just this woman going to Walmart, picking up the medicine, not knowing that it's medicine, and then going to another place, and then going to back to church to join the rest of the family. So we need a specialist tool to answer those questions. Can be, in-depth questions of the same diary, can be the time used, which is very expensive in terms of effort and money to collect and to code, or qualitative. We can come up with ethnographic type of analysis and look at the families and how they coordinate and who does things for others and things like that.
So that brings up something, another interesting piece of all this, and that's where the data comes from. Mm-hmm. And, we've been in the individual travel survey business for a long time. And, the sort of traditional workhorse has been these surveys like the California survey or like NHTS. But we're awash now in cell phone data and trace data and all kinds of things, right? And I'm wondering if you, as the travel behavior expert, have thought about sort of the next generation of travel survey.
So we are all working on that. A few of us, but not everybody agrees, of course, think that the next generation probably is going to be an app, a phone app, that you ask volunteers to install in their phone for some incentive, and they track the individuals around, so you can get the precise locations of where they went and the precise time. And then you ask them key questions at strategically selected times. Prompted recall is the jargon that some people use. I think Kouros has another more advanced technique. Some people in Europe have others. MIT has developed. So it's an app, so you can distribute it in a nice way. I think this is the next generation, and is used already in Puget Sound in conjunction with the main horse surveys. We all looked at the possibility of not asking any questions and just use GPS phone, the locations of phones. It is used, but it gives you an aggregate picture. It's a more sophisticated traffic count, but now it's a person count that you get. That is very, very useful because you can validate your patterns. But we need to know human interactions. We need to know who is traveling with whom and why, right? So the GPS traces don't tell you that I'm taking my daughter to school and then my wife will pick her up in the afternoon. But if you look at the diary, you will know that there is a task allocation. So we need that.
And we don't have the attributes of the the population either.
Yes, but even the ones that we use now, phone and prompted recall, there is one big piece of information that we need to figure out, and that is which vehicle are you using to go from A to B, because then we can figure out the amount of emissions that you produce, right? And if it is an electric car, that you're not producing emissions, so that we can test whether or not our policies of incentives for electric cars are successful or not. And that's how we know, for example, that Prius and the incentives for the HOV lanes were very good, because people bought a Prius just to use the HOV lane, exactly. Not pay the toll.
Now they're buying Teslas.
Yeah, well, they are the same income bracket, The toll facilities in California were called the Lexus lanes, And now I'm going to call the Tesla lane.
Right. Last question. To reduce VMT per capita in a place like Los Angeles, what are the factors that matter?
Why do I have to answer the difficult question? So VMT per capita. One can argue actually that ride-hailing TNC services might reduce per capita, but it's wrong because the Uber and Lyft actually increased the VMT. Right. Now you have the drivers of these cars driving around looking for a ride. So this pooling, this sharing, understood in the sense of the TNC, might be wrong. But I will give you a traditional answer. Better metro. There is no better medicine than VMT per capita than to have a very good subway, a very good metro. In fact, there is the new line, the LAX Crenshaw line, that is going to come to be ready to be used at the end of December, beginning of January, I think. Jen, we have a project on that with you.
I know.
Yes,
stay tuned. So, next year we'll do that one.
Yeah. So the good public transportation facilities and strong restrictions with accompanying high parking costs is the way to go. It is hard politically to do this in California, especially, because as soon as you say parking cost goes up, the local retail owners will go up in a revolution. But good public transportation works very well. And good non-motorized systems work very well. And we see it in Santa Monica, we see it in San Luis Obispo. There are projects around the state where people abandoned their car for short travel, up to 3-4 miles. And now we have also electric-powered bicycles that extend the range of the bicycle. But those have to be done with an eye to safety. Because we are talking also about women, we know that women and men look at bicycles in different ways, especially by time of day. Late at night, it's hard to find women on a bicycle riding around because the perception of security is awful. So lighting and bike paths and separation of movements, everything that is related to safety will enhance the propensity of using bicycles and walking for dense environments, and then the good public transportation for longer distances, like the commuter rail in Los Angeles. Metrolink works very well. So in spite of COVID-19. So.
Okay, there's actually been several questions relating to the survey data. Questions on how, I think we should probably take the California survey as the example, the California statewide survey, and how people are recruited to respond to the survey. What's the universe? How are people selected? And how do people finally end up in the sample?
That's a great question. I can answer it. So the sample frame of the California Household Travel Survey are the addresses of homes, because they don't move around. So you say, okay, this is. And it was the contractor oversampled rural counties so that we can get a sufficient sample size to have meaningful statistics out of them, and undersampled Los Angeles, San Francisco, Sacramento, San Diego. The recruitment happened with personal letters of invitation at each of these addresses, millions of them, and only about 7% agreed to participate.
Mm-hmm.
Once they agree to participate, so it's a tremendous waste of money figuring out. Once they agree to participate, of course, they found out that inner city persons refused at a higher percentage than suburbs. So there was an intense effort there. Recruitment happened through leaders, community leaders, through advertisements by different NPOs. Caltrans took a big part in all this. We were advocating to also have the governor and the mayors. That did not happen for a variety of reasons. The retention was also hard because you first recruit them, they say, yes, I will participate. Then you give them a questionnaire, who you are, what did you do, where are your kids? And then they say, oh, what are the locations of your kids' school? Ooh, no, I don't want to tell you. So you have to go through a convincing period. Very good was the online tool of showing the map and what the person did in a day. Both the NHTS and the CHTS and many household surveys attempt always to have a complete household. Every kid, every grandfather, everything in between. And that's because then we can, most of the human interaction that happens, especially for traveling, is within the household. We do have interaction with other people, but if we get that right in our analysis, we get something. So just to give you an idea, 114,000 people, daily patterns cost the state about $12 million. So it is an expensive.
Which is why we're still working on that
Yeah. That's right. And the blessing was an HTS that came, 5 years later. So now we have another wave cross section, and maybe we'll get another one later on. But there are all kinds of efforts to do smaller surveys that are purpose-built and then stitch everything together. But stitching everything together requires quite a bit of science behind it.
So this has been a great conversation after a great presentation. So I want to thank you so much. I think we have virtual applause. I think that's about all that we can do here. But I want to thank you so much. Thanks to the TRB committees that sponsored this. The webinar has been recorded, I should say, and will be available on our Metrans website pretty soon, pretty quickly, for those who want to take another look or tell their friends how great it was to take a look. Or we may even assignment in one of our transportation classes, who knows?
That's right.
Right.
No test at the end.
Right.
Thank you very much. It has been a pleasure.
Thank you so much.
Thank you.